Alright, so this is the second period video. We're going to go through 2, 5, 8, 11, and 14. Obviously, if you're looking for other problems, they're posted elsewhere. Alright, number 2. A rectangular area is to be enclosed by a wall on one side and fencing on the other sides. Okay, smart use of, there's a wall there, so you don't have to fence that side. You only have to fence the other two sides, 2 lengths and a width. Or maybe that's 2 widths and a length, doesn't really matter. 18 meters of fencing are used. What is the maximum area that can be enclosed? So area, if we're trying to maximize that, length times width, that would be our primary equation, because that's what we're trying to maximize. So eventually I want to take a derivative of that, set it equal to 0, figure out where the max area is. I don't want to take a derivative yet because there's 2 variables, so that would be a pain to deal with. But there's 18 meters of fencing, so L plus W equals 18. And if you set this up different, if you call these W's and this L, obviously we're going to have different things going on in the middle, but you're still going to land with the same maximum area. Okay, so I want to take a derivative of that, but not yet because there's 2 variables. But I've got a helper equation over here, a secondary equation that I could solve for either one, but it looks like W would be a lot easier to solve for. I mean, not a lot easier, but a little bit easier. So W is 18 minus 2L. Then I can take 18 minus 2L and plug it in for W. Now I've got an equation with 1 variable in it, so now I can take a derivative, but I don't want to take a derivative yet. I could, but it would require the product rule. What would be a better choice of a next step? Yeah, distribute. Do a little algebra first. 18L minus 2L squared. Now I'm going to have a relatively easy derivative to take. 18 minus 4L. So I'll set that equal to 0, right? Because I don't know what the equation looks like, but maximums and minimums happen when the slope is 0. So I'll set my slope, my derivative, equal to 0. So L equals 9/2. Answer choice A looks appealing at this moment. But why is answer choice A not correct? Because we're looking for area. So L is 9/2, but that's not what I'm looking for. I want to find the area. Okay, so how am I going to find the area? I guess I could use an area equation. I could find W and then do L times W, but I think it would be easier to just grab one of these L equations. I think I'm going to use this one. Any of the area equations would work. 9/2 times 18 minus 2 times 9/2. I picked that one just to avoid squaring 9/2. So 9/2 times 18 minus 9 is 9. 9 times 9/2 would be 81/2. So that would be my maximum area. 9/2. Width ends up being 9. And because I've done this problem 100 times before, I sort of knew how to draw my picture to make it work ahead of time. Sarah?
Could you plug L back into the secondary equation and find it like that?
Yeah, absolutely. And in some ways that's like more intuitive because if you're like building this, you want to know how wide to make your fence. So 18 minus 9 is 9. So if you got W and L, you can multiply those together to get the area. Number 5, with calculator. A particle moves along the x-axis so that any time t greater than 0, its velocity. Okay, so I'll be looking at velocity. What is the acceleration of the particle at time equals 4? Well, how do I get the acceleration if I know the velocity? The derivative. So I want dv dt at t equals 4. Write out some stuff and then go to your calculator. Let's see. That one's not awful. Like, I could do that by hand, but why bother? Like, I've got the calculator. 3 plus 4.1 cosine 0.9x. And I can do this on the graph, or I can do it on the main screen. It doesn't really matter. Math 8. Bars. So I put that in for y1. So I want the derivative of y1 at x equals 4. 1.633. On one that's so straightforward like that, I probably do it on the main screen. If you want to do it on the graph, you can. Window's a little messed up from earlier. So there's t equals 4. The slope is positive. Second calc, dy dx at 4. And so my slope is 1.633. So either way, it seems like some of you have a preference for looking at the graph and doing it, and some of you have a preference for doing it on the main screen. And it doesn't matter. Take your pick. Number 8. A bug begins to crawl up a vertical wire at time t equals 0. The velocity of the bug is given by the function whose graph is shown on the right. So this is velocity. So be careful, this is not a picture of what the bug is doing, it's a picture of his velocity. At what value of t does the bug change direction? Okay, change direction. So forget the picture. What does change direction mean in terms of position, velocity, or acceleration? How would I know a change of direction? Yeah, you're doing this, but what is that in terms of a or v or x? What's changing?
The sign of v.
The sign of v. So I want a change in the sign of v, or v changes signs. So v changes signs at t equals 6. Maybe at t equals 8, but we don't really know what happens after 8, so I can't say, maybe it bounces down, who knows. But definitely at t equals 6, velocity changes signs. That's one of those that's, like, computationally, it's super easy. There's really not much to do. Conceptually, you have to know that change direction means v changes signs, and then you're looking for where does v change signs. Number 11. The position of a particle. I don't see that this is calculator, and it does have sines and cosines, so let's be careful. The position of a particle moving along the x-axis is x equals, so this is position, for time greater than 0. When t equals pi, the acceleration of the particle. Okay, so v is dx dt, so I'll need to take a derivative to get v, and then I'll need to take another derivative to get a, and then I'll plug in pi. So derivative of sine is cosine. Chain rule is 2. That's probably going to get some people with the chain rule part. The derivative of cosine is negative sine, so this becomes plus sine of 3t times 3 from the chain rule. And then acceleration means I need another derivative. Derivative of cosine is negative sine. And another 2 pops out because of the chain rule, so 2 times 2 is 4. Derivative of sine is cosine. And a 3 as a result of the chain rule, and 3 times 3 is 9. And then I want to evaluate that at t equals pi. So negative 4 sine of 2 pi plus 9 cosine of 3 pi. Okay, 2 pi is right there. The sine of that is 0. So negative 4 times 0 plus 9 times 3 pi would be 2 pi around plus another pi around would put me right there. Cosine is the x-coordinate, negative 1. So my answer is negative 9. Kind of surprised negative 1 isn't a choice, because if you forgot the chain rule, you'd think the answer is negative 1. Lastly, at least lastly for this video, number 14, particle moves along the x-axis so that any time t greater than 0, its position is this thing, where a is a positive constant. For what value of t is the particle moving to the right? And lots of concepts covered here. Moving to the right means velocity is positive. So I need to find velocity. That would be the derivative of position. So 1/2 times 2, bring the 2 down, a minus t to the 1, times, chain rule again, the derivative of a minus t. A is just a positive constant, so that's like 5 minus t. Well, the derivative of 5 minus t would be negative 1. Let's clean this up a little bit. So negative a minus t, or just t minus a. So one little calculus step, take one derivative, not even a hard derivative, and then I want velocity to be greater than 0, so I want t minus a to be greater than 0. So that means t needs to be greater than a. If you forget the chain rule, you'd pick option A, because that negative sign would switch things around. I don't really... t equals a, that would be where velocity is equal to 0. That's not it. I don't... Yeah, some of those others is just like, we're just trying to come up with some other alternative answers here. Questions on that one? Okay. So that ends the second period video. Again, if you're looking for other problems, check that Word document or that Google Doc, and it's got the links to the other problems in there.